These are the problems from the first in-class quiz, quiz 1. And we had 3 problems, and let's just take a look at those. All right, the first one says that a person buys 5 books at $46 each, and they pay for them with $10 bills. How many $10 bills did it take? So what we need first of all is what was the total amount of money that the person spent. So we had $46 times 5 books. 5 times 6 is 30. 5 times 4 is 20. Carry that 3, right? And so the person spent $230. And they paid for this with $10 bills. So we had a total of $230 that we spent. And we paid for it, he paid for it, they paid for it with $10 bills. So we're asking ourselves, if we have $230, how many groups of 10 or how many $10 bills would it take or could I make out of the 230? So we just do a simple division here. And we get 20, subtract, bring down, divide, remainder is 0. And so we can tell that it took 23 $10 bills. Now I can check this pretty easily by simply saying, well, $10 times 23, yep, comes back, and this is multiplication here. And let's see, this was multiplication here. So the answer is 23 $10 bills, so that's answer choice A. This one is a little harder. We had to remember the order of operations and its fractions, so that's always a little bit aggravating. So let's start off here with, can we do some work inside of the grouping symbols, these parentheses? And we can. So I'll try to fit all this in here. So I'm going to have 5/8 minus 1/6, and that is going to be multiplied times the quantity that will remain inside of these grouping symbols. And so what we want to do here is we want to combine these two fractions, and we do not have a common denominator. So let's kind of work on that over here. I want to add 1/4 to 4/5, so I'm adding here. And I need a common denominator. And it appears the lowest common multiple here happens to be 20, 20. And so I'll simply multiply this times 4 and this times 4. Remember, when we convert a fraction from 1 to an equivalent fraction and we use multiplication, if I want to change my denominator here and I want to make it a 20, I multiply by 4. I also have to multiply by 4 in the numerator, because if you remember, this is the idea that a number over itself is 1. Now we get different looking numbers, but we're talking about the relationship of 4 things to 5 is the same as the relationship of 16 to 20. Up here, same logic, and I get 5/20. Now, I'm now going to add this together. 5 plus 16 is now 21/20. Now, that is an improper fraction, but I think and I could convert it to a mixed number, but I think for purposes of the multiplication, I'm going to leave it just as it is. Notice now we've done the inside here, the parentheses. There's no exponents. It then says, it says you multiply and divide. You multiply and divide in order before you add and subtract. So what's the next arithmetic I can do? Well, I'll do this piece of multiplication here. Now, stop and think about that for a minute, because the tendency is to go ahead and do the subtraction, but no, we don't do that. We do this multiplication. So when I multiply 1/6 times 21 over 20, I'm going to get what? I'm going to get 21 over 120, and then 5/8 is going to get the subtraction problem done. Notice we're doing subtraction now, and we have a similar problem in that we don't have common denominators. So let me come over and we'll try to work this here. Take away 21 over 120. And this one could be a bit of a challenge if we're trying to find the lowest common multiple, which is what we are. And so let me see. I think I might can squeeze this work in down here at the bottom maybe. So I'm looking for the lowest common multiple between 8 and 120. And without doing the table of multiples, I think what I'm going to do is I'm going to use factorization. And we'll say, well, 8 factors into prime numbers like this. 120 factors into, this will take a little thought, but it's going to factor into, well, first, I can go 2 times 60, all right? And let's work off of 60 a second. That can go 2 times 30. And then that can go 2 times 5 times 6, and then furthermore that can go 2, 5, 2, 3. So that's kind of complicated, isn't it? So what I said is, well, first of all, 2 times 60 is 120. Then I said, well, let me work on 60 for a minute. 2 times 30 is 60, and then 5 times 6 is 30, and then 6 is 2 times 3. So when I package all this together, I'm going to write these in the sequence of the prime numbers. So I had 2 here. I have these 2 2's over there, which takes care of those. I then have a 3, and then I have a 5. Now let's just check and see if this is still 120. 2 times 2 is 4, times 2 is 8, times 2 is 5 is 40, times 3 is 120. Oh, okay, so I feel good. So now, remember how we do this lowest common multiple, which is going to be my lowest common denominator work? How do we do that? We bring down each of these factors, the greatest number of times they occur in any one factorization. So it says here that I'm now going to bring down the 2's, the greatest number of times, and I'm going to bring down the 3's. And so curiously enough, it turns out in this case that the lowest common multiple is going to be 120. That's a little bit surprising. I was thinking we might find something prior to that, but apparently we're not. So come back to here. So this one already has 120. And so now the question is, what must I multiply times 8 for it to become 120? Well, you can see what's left down here to multiply times 8 so that it becomes 120. 15. 3 times 5 is 15. So if I multiply 8 times 15 and 5 times 15, I get 75 over 120. And I do my subtraction, and I get 5 minus 1. I'm kind of running out of room here, getting a little sloppy, but 5 minus 1 is 4. 7 minus 2 is 5, and so I get 54 over 120. So I'm going to bring that down here because I'm going to need to simplify that. So I have 54 over 120, and what can I divide into this? Well, just thinking about it without doing factorization, think about it. Divide this by 6 and this by 6. And what does this become? 54 divided by 6 is 9. 120 divided by 6 is 20. And I think that's it. See, now why do I say that? Because just quickly do this factorization. 3 times 3, and then what? 2 times 10, right? Which is this. There's no common factors in here to cancel out. So the answer to this one must be 9/20. And yep, here it is. And so the answer to this one is 9/20. That was a hard problem. I mean, that one was definitely not easy. Okay, well, let's do this last one. We have $901. That's the amount we're going to start with here. And I'm going to write some checks, all right? I'm going to write these checks. So I think what I'm going to do, and then I put a deposit in. So these are all going to be subtraction amounts, and then I'm going to add an amount. So let me combine all of these. So I'm going to come here and I'm going to add up 48, 56, and 132. 8 and 6 is 14, and 2 is 16. 4 and 1 is 5, and 5 is 10, 13. So the subtraction amount is take away $236. So let's do some subtraction here. 8, 9, 10. Do some regrouping. 11 minus 6 is 5. 9 minus 3 is 6. 8 minus 2 is 6. Now that's the amount that I have after I deduct. So these are my checks. And I'm deducting that from what I started with. This is my, you might call this your beginning balance here. So now I have this amount of money, and then I had to make a deposit. So I'm simply going to add 129 to this. This is my deposit here coming in. 5 and 9 is 14. 6 and 1 is 7 is 2 is 9. 6 and 1 is 7. So I have 700 and, what is this? 5 and 9 is 14. 6 and 1 is 7. So I have $794. $794. And so that's answer choice B. All right. So there's your 3 problems on the first quiz. I'll kind of leave this up just for a second, so you can kind of look at the work. This one was simple, I think. This one was actually this was a difficult question because we had to remember how to do all this fraction, equivalent fraction stuff. This one was hard, and then we had to simplify it at the end. This one was just basic addition and subtraction. So this one, and you'll notice I didn't use a calculator. I didn't use a calculator on these. You could use your calculator. I just chose not to because I wanted to show you the manual steps. So that's quiz 1. And I think that's enough.